Hello friends, today I'd like to show you the retrofit build of the JK 304. This is my design. JK means it's a JK BMS, 200 amp-hour capability, and 304 meaning the EVE 304 amp-hour cells, and to its size it's a 200 amp-hour collapse cells. This is the older version. I don't think it's in production anymore. It's 200 amp-hour. This is 304 amp-hour, shorter and slightly skinnier. And this is the original cover. The cover been pretty bad shape. And so what I did is I put in new insulation strips. These are pretty high density insulation strip, and also put a fresh coat of paint on it. So this is painted on the top and also all around on the side. So let me show you the special feature of this design. It has a heater for cold temperature charging, and it also has a high voltage on controller. This high voltage on controller will only turn on when there's external charge source applied to the battery. It will not drain the cell itself. It will not drain the battery itself. It rely on the external power supply to heat up the heater. And this is programmed to be turned on at 13.5 volt and turn off at 13.4 volt. So if the battery is higher than 15.4 volt, it will draw down the battery first. Typically 13.4 is almost like a 98% of a state of charge. So it only draw down very little, not a whole lot, until it sees a external power supply or external charging source which is higher than 15.5 before turn on the heater. So this is the retrofit battery. Let me open it. This battery is all tested and assembled. It's brand new cells and brand new components. And let me show you what I did with the insulation strip. So the insulation strip is all applied all around. It's high density, and it should protect the battery better under any low environmental condition. So the feature I really want to show you today is the high voltage on controller, and here's the setup. As you can see, the controller is underneath there. You won't be able to see very clearly, but this is the controller right here. Okay, anyway, the controller right now is standby, meaning it's basically off, not just standby, it's off. So if I simulate the turn on temperature, typically it's set at 1 or few degrees Celsius. If I simulate that and turn it on at room temperature, so I would put in let's say 18 degrees Celsius. And as soon as I put in 18 degrees Celsius, you should be able to see the LED display turn on in the controller. Okay, ready, go. Okay, just turn on. You can see the red display. That's the LED display. But right now the battery is only at 12.83 volts. So battery is only at 12.83 volts, and there's no current going through the heating pads. So these are the heating pads, two of them, one between cell 1 and 2 and one between cell 3 and 4, and there's no current going to the heating pad. So what I want to do is I turn on the charging source, okay, now it's charging at 14.45 volts, and as you can see, because it's cold temperature, it's not charging, but you see a current is 3.72 amp. The 3.72 amp is actually going to the heater to heat up the battery. As you can see, my measurement ammeter is not very accurate. It shows about 3.5 amps. So this is working per design. First of all, you need to have cold temperature to turn on the to arm the heating function. Just arm, not heating. And then it needs to have an external charge source to power the heater so that you don't drain the battery. And this is the small display of the JK 304. It shows the state of charge at 100%, and the cell voltage is 13.3 volts, and the current is 0 right now. Now, this BMS energy capacity has not been calibrated, so that even though it's only 13.3 volt and 100% state of charge, clearly that's not accurate. You take multiple discharge down to 0 and charge it back up again for it to be calibrated. So go back to the design. How do I handle the height difference? So what I did was I buy some of this electrical outlet, and I grind off the end and then glue two of them together. So grind up the end, glue two of them together, and put it underneath the cells. You just raise it to the perfect height of the box. As you can see, this is the height of the box. And because the cells are also narrower, so what I did is I get some high density foam. This is the high density foam. I stick it to the top side of the cell, and so that it fit perfectly inside the box again. The cells are laid sideways because of the design of the box. So this is the box. The cells are laid sideways, so the cells are actually sitting down this way, and then the foam is on top. So the foam is on top. This has been a very reliable design. It has been tested by a lot of people in the internet, and I also have tested a few versions of this JK design, and this being the latest one with the fully automatic heating function and very good features. So thank you for watching. Have a good day.